So what I can do is I can calculate the point of intersection by using the two equations of the lines and then find the distance between the points just to make sure I have the right ones. So we have y equals 1/2 x is the equation that was given to us. And then I have the other line, which is right above it, y minus 1. If you hear my 3-year-old yelling at me, my apologies. Apparently I left his cereal in the wrong place because that's an issue. Okay, I want to know where these two things cross. When we try to find points of intersection algebraically, you guys have been taught mostly to get them both in y equals 4. So I'm going to get this guy in y equals 4. Y plus 0 is really just y. And then when I distribute the -2, I get -2x plus 10. And if I want to know where they cross, I'm going to set 1/2 x equal to -2x plus 10. And I need to solve for x, so I'm going to add 2x to both sides, which gives me 2.5x equals 10. I'm going to divide by 2.5 and get x equals 4. And if x equals 4, and I substitute it back into either one of these equations, y is 1/2 x, so y is 2. And that was this point up there. So I got the right point. The only purpose of that was, hey, if you graph it and you can't see a nice what's called lattice point with like integer coordinates, you could always write the equations and see where they cross. Okay. Now, we're about 13 minutes in or so right now, so I'd like to find this last distance, and then I'll be done, and then you guys can work on the problem set on your own. There is a graph paper if you need it with each of these, and I say if you need it, but really I mean when you need it. So let's try to do this last example. I will do it with you. We will be done, and we will move on. Find the distance from 7, 2, to the line y equals 3x plus 1. So y-intercept of 1, slope of 3. And I think I graphed everybody appropriately this time. Oops, shifting the thing here. So like my little song. Okay. So from 7,2 to 3x plus 1. And then you're just going to find your perpendicular slope and figure out what goes on here. Notice this time I didn't scaffold the question. I just said, hey, let's do it. Not giving you all the tips and tricks. We're just going to do it. If you want the distance from a point to a line, you need to draw a perpendicular. So right now the slope we have is 3, which means our perpendicular slope is -1/3. Who said that? I did. So my perpendicular slope here should be -1/3, and I should be doing it from this point. So I should go down 1, right 3, or up 1, left 3, up 1, left 3, up 1, left 3. Okay, so I ended up hitting this point. So that's my perpendicular distance that I want to find. The point in question was the point 7,2. I bonked into the point 1,4. So if I want my perpendicular distance, I'm finding the distance between 1,4 and 7,2. So my delta x is 1 to 7, which is 6. And my delta y is 4 to 2, which is 2. And that's going to be 36 and 4, which makes the square root of 40. Now, I didn't tell you what form to leave it in, but let's just do simplest radical form to remind ourselves how that works. So 40 is really 4 times 10, and the square root of 4 is 2. So our final answer is 2 root 10. So long story short, if you want the distance from a point to a line, you need to draw a perpendicular segment to the line and calculate the distance that way. You don't have to write this note unless you think it's going to be helpful to you, but I wanted to just recap everything. So the distance from a point to a line, you draw a perpendicular segment to the line and calculate the distance that way. All right, so now I need a joke because I always end with a joke. Let's see, the joke today is going to be, what did the giraffe say when it swallowed the toy jet? So a little giraffe was playing with a little toy jet and it swallowed it. What did it say? It said, "Oh, what a pain in the neck." Ha 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 ha. I know that's not a very good joke, but let's see. I'll give you a pirate joke. What's a pirate's favorite kind of movie? Movies rated R. Why can't pirates ever play cards? Because they're always standing on the deck. All right, I'm done now. Do your homework. It's that problem set, and you should be all good. So happy graphing. Bye.